Today we're going to be looking at learning target 6A, which is being able to solve a system of equations by graphing. As you're taking notes, please make sure you include these 5 things. You're going to be looking for what is a system of equations, how you can check an ordered pair to see if it is a solution for a system, how you can solve via graphing using paper and pencil method, and how you can use your graphing calculator to find the solution as well. And then also at the very end, you're going to have a series of practice problems. Please pick 2 of them and go through and solve them. So to begin, let's talk about what a system of equations is and what it means to solve them. So a system of equations is when you have 2 or more equations that intersect at the same set of unknowns. So the way that we solve it is we're trying to find that place where all of the unknowns, the variables, are the same. So where it works for all equations in the system. Now for the sake of this unit, we're going to be looking all at linear functions, and we're going to find the place where they intersect. And there's 3 ways that you're going to learn this unit about how to solve a system of equations. The first method, which is what this video is about, is the graphing method. And we will shortly, throughout this unit, learn about the substitution method and the elimination method. Let's start by looking at the graphing method. So first thing we want to be able to do is find out, is this ordered pair of 3, -1 a solution for this system of equations? So the way that we can do that is we're going to take the x value of 3 and that y value of -1, and we're going to plug it into both equations. And we want to know, does that make the equation true? So you can see I plugged 3 in for x, -1 in for y into the top equation. That's my red equation here. And I plugged 3 in for x and -1 in for y in the bottom equation, which is represented by the blue ink. Now I just need to go through and solve and find out, does the left side and the right side equal in both equations? So as I work through this, with the red equation, I do find out that 5 does equal 5, so that checks out. And with the blue equation, I find out that 7 does equal 7, so that one checks out as well. So since that ordered pair worked in both of the equations, that means that it is a solution. So the solution for that ordered pair is 3, -1. Let's look at another example. So again, we have a system of equations and an ordered pair that we want to check to see if that is the solution. So first step is I'm going to take the x and y values from that ordered pair and plug it into the equations. So you can see I plugged 2 in for x and -2 in for y into both equations. And I just want to check out to see if the left side does indeed equal the right side. So with the top equation that's in red here, we do get that 4 does equal 4, so that checks out. But with the bottom equation, when I go through and solve, I get that 8 equals -4, which we know is not true. So since this ordered pair does not work in both equations, that means it cannot be the solution for this system of equations. To make more sense of this, let's go ahead and learn about how to solve it graphing using paper pencil. So here's a system of equations, and we want to graph it to find where that point of intersection is. So I'm going to start with this top equation. Notice I have no y-intercept. There's no number there, which means that it's going to cross at 0. My slope is 1/2, so from there I'm going up 1 and to the right 2, up 1 to the right 2. Once I have 3 points, I can create my line. So there's my red line, represents my top equation. Now I'm going to work on that bottom equation. I've got a y-intercept of 3, and my slope is -1. So we know the y-intercept is 3. -1 means I'm going down 1 into the right 1, down 1 into the right 1. And you can see that these 2 lines cross at this point 2, 1, which means that that ordered pair 2, 1 is the solution for my system of equations. Now I can then go back and check my work. I can take that 2 and plug it in for x, take that 1 and plug it in for y, and check my work similar to what I did at the beginning of this video, and it will work out. So 1/2 times 2 is 1, which my y value is 1, and -2 plus 1 is 1, which is is my y value as well. So that one does check out. Let's look at another example. So again, I've got a system of equations. I'm going to go ahead and graph my first one. My y-intercept is -2, and my slope is 1. So I've got -2, my slope is 1, so I'm going up 1, right 1, up 1, right 1. I can create my line there. The second equation is written in standard form. So I've got to find where the x and y intercepts are. So 2 times what equals 1? I know that my x would be 1/2. 2 times 1/2 equals 1. So my x-intercept is going to be 1/2. My y-intercept, 1 times what equals 1? Well, my y-intercept would be 1. So when I graph this, I got my x-intercept of 1/2, my y-intercept of 1, create my line, and I see that it crosses here at 1, -1. So again, I could go through and check my work. 1 minus 2 is -1. 2 times 1 minus 1 is also 1. So I know that that solution works in this case. So when it comes to solving via paper pencil, graphing your lines, looking for that point of intersection works out great. But there is a way that we can do this using our calculator. As long as both equations are written in slope-intercept form, we can go ahead and plug it in and see what we get. So, first thing, turn on your calculator. You're going to go to y equals, and I should say go ahead and watch it at this point because the next slide will have all the steps. So I'm going to go to y equals, I'm going to plug in my top equation. So in parentheses, the way you do fractions is in parentheses do 1 divided by 2, close parenthesis. Your x button is to the right of that alpha button, plus 2. Then I'm going to go down to my y2, and I'm going to plug in my second equation. So negative x, make sure you use that negative button whenever it's not an operation. So I've got my two equations. Okay. If I want, I can hit the graph button and look at the two graphs. And I can see kind of where it's going to cross, but it's really tough to tell. But the nice thing about these calculators is that it will tell you where it crosses. So right above trace, you can see there's a calculate button. And the way I get that is I'm just going to hit the second button and then trace. And I'm looking for the point of intersection. So I'm going to go ahead and hit 5. It asks me where the first curve is, and so you're going to look for that cursor, and anywhere on one line you're going to hit enter. Then it's going to ask you about that second curve, so notice that my cursor jumped to another line, so I'm going to go ahead and hit enter. Then it asks me to make a guess, so I'm just going to use these left and right arrows to get as close to that intersection point as possible, and then I'm going to hit enter. So notice it tells me my intersection is when x is -2 and my y is 1. So I would write that as an ordered pair of -2, 1. So as promised, here are those steps. Please make sure you write these down so that you have this in your notebook so that you can use this for future types of problems. The next page are some practice problems. So if you have a graphing calculator, feel free to use that. Otherwise, please try the graphing method by hand in order to solve these. So here are 6 problems. Go ahead and pick any 2 of them. Make sure they're in your notebook. And pause the video, and the solutions will be on the next page. So here are those solutions. I want to call special attention to number 4. Notice that it says no solution. That one is no solution because when you graph the 2 lines, they're parallel. They won't ever cross. So you have that idea of no solution. All the rest cross in just the 1 point, so you have 1 solution there. There is also the possibility of infinite solutions. So if when you graph your 2 lines, they fall directly on top of each other the whole way, you would have infinite solutions. So that's how to graph a system of equations and find a solution. Please come to class with any questions.